Joining me is a man who's very familiar with the moon and everything around it, retired NASA astronaut Captain Mark Kelly. Captain, so great to have you here. Can you just explain the significance of this lunar eclipse? What makes it unique?
Well, this one's pretty rare because it's a full lunar eclipse, and it just happens to be the situation where the Earth is about as far away as it gets from the sun, and the moon is also relatively far away from the Earth. So the Earth is casting a big shadow, and then the moon is going through the big part of the shadow that was cast. So it transits it a little slower, and it's a bigger shadow. So it's going to be in there for about an hour and a half. The biggest possible lunar eclipse is about an hour and 47 minutes. That happens very rarely. So this is a long one.
What is it that makes it a blood moon, and why is it called that?
Well, so the sun is not shining directly on the moon when you see a lunar eclipse. It's in shadow, but it does get some sunlight that is refracted through the Earth's atmosphere. And as that sunlight passes through the atmosphere, now the Earth is round, right? Let me say that again to those people who might be in doubt. The Earth is round, and the moon is round. And as that sun passes through the atmosphere on the edges of our circular disk, the round Earth, the blue light gets filtered out. And the wavelengths that come through are the red wavelengths, and that is casting a red, basically like a red flashlight on the surface of the moon.
It's amazing. You've seen the moon from space. What does it look like from space compared to how it looks on Earth?
Well, on a clear night on Earth, you can see it really, really well. In space, we have the added advantage of that we're not looking through, 100 miles of atmosphere above us. So it's just through a vacuum, so you see it much more clearly. Clouds are not going to get in the way. Especially if you use a pair of binoculars, you could see detail on the moon that you can't see from the surface of the Earth. I'm here in Hawaii right now, and it was a clear night last night. And with Mars being really close, we were taking a look at Gabby and I were taking a look at through Mars through binoculars, and then the moon as well. And it's pretty incredible, the detail you can see on the surface of the moon.
That's so cool. We've got some questions from our viewers for you. Evangelist wants to know, is there a danger for the eye to watch the lunar eclipse directly as with the sun eclipse?
Absolutely not. You can stare directly at it. You can look at it through a telescope or with binoculars. The sun is on the other side of you. Now, unfortunately for us here in North America, you're not going to see this lunar eclipse at all. You got to be on the other side of the planet, the night side, while this is happening. But any lunar eclipse, you can stare right at it without a filter.
Rachel wants to know, when do you think man will be able to travel to Mars, or woman will be able to travel to Mars? Will it be a one-way trip?
Well, I am not in favor of the one-way trip. We understand the rocket science pretty well of what it would take to get to Mars. My brother spent a year in space to try to help us understand the physiology of somebody spending a long time in space. And a mission to Mars and back, you're looking at about a 2.5-year mission, so they would be pretty long. But beyond that, the thing that makes this really hard is the political science. I think we all are aware how hard it is to get things done in Washington, D.C. Federal government tends to change its direction on things all the time, so we would have to have a Congress and a president and the American people behind that mission. And if we had those things and we did it over a period of time, we could go to Mars. We could probably do it in 10 to 20 years from now, but we have to want to do it.